Hi everyone. So we're going to jump into chapter 5 now and start talking about financial mathematics. And for the first section of that, we're just going to be talking about um, interest on either you invest money one time and then you take it out one time later, or you borrow money one time and then you pay it back once later. After that, we're going to be talking about what happens if you borrow money and pay it off in installments, or if you make an investment and get paid in installments. But for now, there's only two things to worry about: one payment in and one payment out. And so the first type of interest we're talking about is simple interest. And simple interest means that you're charged some percent, you can see that here, of the principal value. So in this example here, you take out a loan of $100 and you charge 5% simple interest. Now what the simple refers to is that you're only ever going to be charged this 5% of $100. So this is a pretty high interest rate, it's 5% monthly. And what that means is that every single month you're going to be charged 5% of $100. Now, 5% of $100 is $5, so every month you're going to get charged $5. So you start off owing 100, and then every month you owe $5 more, 5, 10, 15, and then in end months you owe 100 plus 5 times the number of months. So it's simple because when we look at these values here, every time we go forward by one, we're going up by the same value. And if you recall, that is exactly how linear equations or lines are defined. So, I can go over to the side here. I can plot, okay, month 0, I owe 100, and that's right there. In month 1, I owe $5 more than that. In month 2, I owe $5 more than that. In month 3, I owe $5 more than that. And we can see a straight line being plotted here. And so, and what the line is exactly isn't too hard to see. You start at 100, and then every month you go forward, that goes up by 5. So, sorry, 5x. And so if I plot 100 plus 5x, x is the number of months, you go up by 5 each step, and that's exactly the line being described here. And if you are reading the document, then you can go ahead and look at exactly that line here. And if you want to go ahead and change around and see how much money you owe in what month, you can just drag this around and you can see that. So in 14 months, you would owe $170. So simple interests are simple because they're just linear equations. And we can see there's a general formula. If you take out a loan for P dollars, and then you get charged R percent or an R rate per time unit, and these don't have to be months, they could be days or years or whatever, then the amount you'll owe in the future A is just whatever you owed times 1 plus the number of months or time units accumulated times R units, or R rate. And so this is the line that has y-intercept p, and the slope is just the rate times p. It's just however much money you're accumulating every single time. So here we have a general example of that. This is the same thing we had before, right? But I can change it so like if you initially borrowed like $200, then not only do we owe more money at first, but if our rate is still 5%, we're getting charged more per month because now 5% of 200 is $10. So the slope is $10 a month. That's how much more money you're accumulating. And if you change the rate to something lower, then we would start with $200, and now I only accumulate $1, 1% a month, which translates to $2. But either way, all you gotta do is think about how much you owe at first and how much you're gonna get charged each month, and you'll automatically get y-intercept and a slope, so you get a line. So there's like nothing new happening at all here compared to what we did before. All right. So the thing that's a little bit more interesting is compound interest. So let's say once again you took out a loan for $100 and you're getting charged 5% compounded monthly. The compound interest means that not only are you going to get charged 5% on your $100 here, you're going to get charged 5% of whatever you owed before. So you start at 100, and the next month you get charged 5% of that 100. So you add 5 to your debt, and so now you owe 105. In the next month, though, you're not just being charged on the 100, you're actually being charged 5% on the 105. So now you owe 110.25. And in the third month, you're being charged 5% on the 110.25, not the 100. So now you owe 115.405. And what's happening is every month you're taking what you had before and you're adding on 5% of what you had before. So in essence, every month going forward, you're multiplying your debt by 1.05. So in n months, you're going to owe 1.05 to the n times the original $100. And so if we were to put a graph of this up, it's something like this. So we start at 100, and every month going forward, you get charged 5% of what we did before. Now, this graph's curve is a lot different than the other graph's curve, and that's because not only is it going up, your debt increasing every month, but the amount it increases by increases every month. So this rate of increase gets higher and higher. So if we compare that to y equals, was it 100 plus 5x, right? This is what you would be, let's change the color. This green line is what you'd be charged if you're being charged simple interest, and this red line is what you owe if you're being charged compound interest. Now, almost everything in life is actually dealt with through compound interest. And so this is really what we care about in this context here. And just like before, we can generalize this. If you borrow P dollars and you get charged I rate per whatever time unit, then in N time units, this is how much money you owe. A is equal to P times 1 plus I to the N. And again, we could see some generalization like of that here. So if I change it to 200, then not only do I owe more initially, but that rate also goes up faster. If I change the rate, it goes up slower, but you can see it still builds pretty high. Now, something that is hard to do in terms of talking over these videos, so I laid it out here, and I might write up or might record a supplementary video showing some board work, but there's a real stupid sort of process where, how do I put this? Financial companies don't honestly publish what their actual interest rates are. They'll publish a nominal annual interest rate, but they'll compound that annual interest rate multiple times a year. So for example, you have 10% annual interest, you would think that you would get charged 10% a year. So if you borrowed $100 in 10 years, you'd owe 260 or 9.27. But what they'll often do is they'll say it's 10% a year, but compounded quarterly, which means compounded 4 times a year. So what's actually happening is you're paying a quarter of 10%, 2.5% interest 4 times a year. And so it's not really 10% a year, it's 2.5% every quarter year. So in 10 years, you're only getting charged 2.5% interest per time unit, but now that's 40 time units. So you end up owing a lot more money. And so what we see here as this is a tricky way for uh, financial companies to actually charge more interest without saying so out loud. But there's all sorts of formulas to connect these things, and they're in this write-up, and they're also in the text. But the basic punchline is you just take your rate that they say they're going to charge and divide it by the number of times per year that they charge that, and that's your actual interest rate. You take the number of years that you're thinking about, and you multiply that by the number of uh, times they charge per year, and that's your time unit. And then you can ignore R and T, and you can just deal with I and N, and that makes life much easier. So there are we have this formula here, right, that connects interest rate per time period, number of time periods, initial value, and future value together. And once you have four equations or four variables in the equation, if you know three of them, you can solve for the third one. And I have some examples of that listed out here. But I wanted to point out very importantly that all of these things can be kind of automated with technology. So in this first example here, you take it all home for $500 at 12% annual interest biannually. How much do you owe in 10 years? So interest charged biannually means 6% interest for 20 half years. And so the amount you owe in the future is your $500 times 1 plus the 6% interest to the 20th. But I wanted to point out that under the compound interest calculator on my website, if I'm solving for the future value of this thing, so I have 100 initial value, 6% interest for 20 half years, my future value is 320.7, which is, oops, wait, sorry, $500, $1,603.57, and that's exactly what we said here. And if I want to see a graph of what that change would look like, this is how that money grows over that period of time. All right. So if in the future I'll have $2,000 and I get charged 8% interest a year, and that's a genuine, real interest rate, and that goes on for 20 years, how much was my initial investment? I could go ahead and solve it algebraically, but I could go over here and I want to know the present value. My future value is $2,000. Interest rate is, uh, oops, 8%, and that's going to go on for 20 years. So I should invest $429.10 thereabouts, and there we go, 429.1. So say I want to invest $500, and in 10 years, I want this to be $2,000. And what sort of interest makes that possible? So I know the initial value, I know the future value, I know the number of years that it's going to take place over, and I want to know what interest rate makes that possible. Again, I know one, two, three out of four things. I'm solving for the fourth thing. So we can graph the previous thing if we wanted to. Let's see. So I start with 500. It's supposed to end up at 2,000. And this is going to be over 10 years. The interest rate should be about 15%, 14.87 or so. Yeah, 0.1487. And if I graph that, that shows my money growing over time at that interest rate. And so you might also care about how long it will take for your money to grow to a certain value. So let's say you borrow $1,000 at 24% compounded monthly, and how long will it be before you owe $20,000? Well, you take your $1,000, that's your present value. In the future, you owe $20,000, and that's at 2% a month, really. And so, what we'll see here, right, because it's compounded monthly, 24%. So, let's see, we started with 1,000. We're gonna end up at 20,000, and that's at 2% a month. So the value here, this n, is 151.28, which seems like a long time, except remember that n is months now, right? It's 2% interest per month to be 24% a year. So this is how much you owe in, or it will take 151.3 months to owe $20,000. And so that's only about uh, that's a little over 10 years. 151 over 12 will be about 12 to 13 years. Your $1,000 will become a $20,000 debt. So I hope this helps. Again, if you have any questions, please uh, contact me, email me. I can write up another video or record another video describing a specific problem on the homework in detail. All right, thank you very much. I will talk to you soon.